Okay, so hopefully you took a second and played around with that PhET simulation, and maybe this will be a very quick exercise for you. But you should pause the video and actually write down your criteria for how you can tell gases apart from liquids, apart from solids. So you want to think about, can it be compressed? What shape does it have? It might not have a shape, or it might have a defined shape. So we can say undefined and defined. The same thing applies to volume. Is the volume defined or undefined? You also want to think about energy level of the individual particles. Do they move quickly? Do they move slowly? So if they move quick, that's high kinetic energy. If they move slow, that's a low kinetic energy. You also want to think about the forces between the particles, right? The more kinetic energy you have, the lower the forces are between the particle because they're moving too fast, okay? It's like trying to high-five somebody running down the highway, right? Like in two cars. You can't do it. It would be very dangerous too. So those things would not have any kind of interaction with each other. Whereas if you are simply standing still, it's relatively easy to high-five somebody. So kinetic energy is kind of related to both temperature and what kind of interactions particles might have with each other. Okay, so far, clearly we have been talking about only pure substances. So if you're talking about elements and compounds, those are pure, meaning 100% of the particles are the same thing in any given sample. So if you had a pile of carbon, every atom is a carbon. If you have a pile of carbon dioxide, every molecule, every particle is carbon dioxide. So that's a pure substance. The other kind of matter is going to be a mixture of things. So you can have two different kinds of mixtures, right? And so you have to have at least two different particles in order for it to count as a mixture. You might have two different kinds of atoms. You might have an atom and an element. You might have two different kinds, an atom and a compound is what I meant, an element and a compound. You might have two different kinds of compounds. You might have a whole lot of different kinds of compounds. So for example, I have coffee with cream in it, and there was ice, but now it's melted. That's a phase change. That's coming in a second. So coffee with cream is a complex mixture of caffeine and water and fat from the cream and protein from the cream and a whole lot of different molecules that come out of the coffee when you infuse it with hot water. You pull those delicious flavors out of it. That's a complicated mixture, right? And I can only tell if it's a homogeneous or a heterogeneous. By the way, some people say homogeneous, homogeneous. I don't care how you say it. They're both right. But you can't tell if it's a homogeneous mixture or a heterogeneous mixture until you've let it sit for a while, or until you try to separate it, okay? So in general, heterogeneous mixtures are pretty easy to separate with mechanical techniques, but homogeneous mixtures probably are going to require a little more work, okay? Turns out coffee is probably heterogeneous because if you've ever left your coffee sitting there for a while and you come back, most of the cream has a tendency to separate from the coffee. That means we have different layers in the beverage, right? And so you have to think about homogeneous and heterogeneous on two different levels. Imagine on the particle level, if all of the mixture is evenly distributed, it's homogeneous. If there is clearly one area with one kind of molecule and another area with another kind of molecule, then it's heterogeneous. Okay, and that same kind of thinking applies to what we see on the macro level. The macro level means what you can observe in nature just with your normal senses. Okay, so on the macro level, we might observe two different layers, kind of like oil and water does in Italian dressing, right? And that would be heterogeneous. If we don't observe two different layers, it's homogeneous. So your text, well, this actually comes from an old textbook we used to use. It's from 2012, but it's a way of organizing the matter, and I think that our current textbook has a similar diagram. The point of it is to give us a series of questions to try and figure out what kind of mixture or what kind of substance we have. So homogeneous mixtures and pure substances both look uniform throughout. So, for example, I have this water bottle, right? And inside I have what I think is probably water, because I've been drinking it. But it's not just water, right? Just water, if it was pure water, it really actually tastes weird. It tastes like a complete absence of everything, which nobody wants to drink. You actually do need the electrolytes and stuff that's dissolved in your water. So pure water is not that great. So this is a mixture, believe it or not. Most water is a mixture. It's very hard to get pure water. But it doesn't look like one. So we would choose yes, because there is not a different layer in here. There's no solid, there's no separation. There's no way to tell one part from another. So then we want to think about the particle level. We want to say, does the composition vary? What we mean by that is there one area with one kind of particle and one area with a different kind of particle? And the answer here is probably not. Even though there are electrolytes like sodium ions dissolved in here, they're probably evenly distributed. So there wouldn't be a cluster of sodiums in one spot. So we're going to say it does not have a variable composition, so it's a pure substance. If you think, or maybe you think that the sodiums would be different from the water, which they are, they're different molecules, right? Then you could say yes and get to homogeneous mixture. Okay, so my question for you is, which one do you think it is? Do you think that my water here, which does have electrolytes in it, otherwise it would taste like dirt, you can tell, it says with minerals for taste. Can you see that? With minerals for taste. So there's definitely some ions in this. Do you think that means it has a variable composition, or do you think it means it's a pure substance? Okay, so when we're thinking about the particle level picture, we know that there would be water molecules, and they would be surrounding those minerals, those ions that are in there. And we know that because we don't see any solid particles, right? So there's no minerals that are precipitated, so it's all one phase. That's how we ended up in the homogeneous category. And so I think it probably does have a variable composition, right? Because if you've got minerals and water, that means it varies. It's not just one thing. So it's not heterogeneous. There's not clumps of the salt hanging out in one spot. It is still homogeneous, so that means the salt is distributed evenly. But because we have more than one type of particle, the composition does vary. So we would choose homogeneous mixture for this one. So that's how that works, okay? If I picked pure substance for something else, we would have to ask the question, can it be separated? Can it be chemically separated, actually? So can we do chemical reactions to make it into something simpler? So if you had a pile of sugar, you would start at the beginning and you would say, okay, well, it's matter because it has mass. Is it uniform throughout? Well, sure, it looks like white crystals. So that means it's homogeneous. Then we say, does it have a variable composition? Well, sugar is a molecule. And so if you had a palm full of sugar, there's not a lot of contamination or anything in that. So we would say no variable composition. Every atom, every molecule is the same thing. Every particle is the same thing. So it's pure. Can we separate it into simpler substances? Well, sure. We could burn it. That would produce CO2 and water. We could metabolize it, which would also produce CO2 and water. So those are much simpler than glucose or fructose, which glucose is C6H12O6. And of course, CO2 is CO2 and water is H2O. So clearly CO2 and H2O are simpler, which means, yes, we can separate it, which means that pure substance is a compound. Okay, if we cannot chemically react it to make something simpler, it's an element. So those are your choices. That's how you can use that. I want you to try and make some hypotheses about what you think these might be classified as. You should include solid, liquid, gas. You should include whether you think it's a pure element, a pure compound, homogeneous mixture, or a heterogeneous mixture. Those are your 4 categories.